Hey, Tim DeStasio here, and I want to invite you to my Manual D Duct Design and Diagnostics class Wednesday, February 19th from 6 o'clock to 9 o'clock p.m. Eastern Standard Time. Even if you can't attend in person, everybody that buys a ticket will get a recording of the class so you can still benefit. Now, this class is sponsored by the Energy Conservatory and Chris Hughes, which many of you know will stop by, and we'll also talk about how the True Flow Grid can help us to diagnose ductwork and even help us to predict what the next piece of equipment we install will do with the static pressure in the duct system, whether or not the duct system will work. So it's going to be a design and diagnostics class. But I want to show you just a little sneak peek of some of the things that we're going to be talking about. Now, before we design a duct system, we have already done a manual J and a manual S. So we've figured out what the heat load is on the building and we figure out what equipment we want to use. Or maybe we almost have figured out what that equipment is. Let's say that our manual J calls for a 3-ton unit and we want to pick this air handler right here. This is a 3-ton air handler. 1200 CFM is moving the air that we need it to remove the BTUs that we need it to remove. And notice here that this air handler at speed tap 3 doesn't quite get there at zero point 0.5 inches static pressure, which is kind of our starting static pressure. Well, we can very easily just change the speed tap, and then all of a sudden we can move that 1200 CFM that we were looking for. But unfortunately, we have maxed out this air handler. That may not be a good idea because if anything else happens on the job, then we may not have any more room to adjust that airflow any higher. So what I suggest doing is going with maybe the next air handler bigger. And we do get a 3-ton matchup with 3.5-ton air handlers all the time. Now look what happens when we move from that 037 air handler to the 043. All of a sudden we can now move a little bit more than the 1200 target CFM we were looking for at zero point 0.5 inches static pressure, and we're doing it at speed tap 3. So we're right there in the middle of what that blower can do. We can adjust it up and we can adjust it down, which is a really good thing. So we want to think about that starting static pressure as like our paycheck. And if you've ever looked at your paycheck before everything starts coming out of it, it looks like you've made a lot of money. And that's sort of what we have when we start out with zero point 0.5 inches static pressure. But the next step is to figure out what our component losses are. And our components losses are sort of like taxes and everything else that comes out of our paycheck. So we start out with a total external static pressure, but then we have to subtract the pressure drop of the things that we know are going to be in the system. That can include a supply register, a damper, a media filter, a return grill, even a heater if we're talking about a heat pump, or a case coil if we're talking about a furnace and AC. And so after we deduct all those pressure drops from that total external static pressure, we're left with a much smaller number, and that is what we call our available static pressure. And so, what are the components in the component loss? It's anything that didn't come shipped with your air handler that has a component loss. And so let's do an example here. Here we've got a furnace, we've got a blower on the return side of the furnace, and is our heat exchanger considered a component loss? Well, no. Our heat exchanger came shipped with the furnace, so that is not considered a component loss. That's part of that air handling apparatus. But the return grill that manual details us to deduct zero point 0.03 inches static pressure from, that is a component loss, as well as our filter. Now, filters can drop anything from zero point 0.1 to 0.15 or even higher. So if we do have an external media filter, we need to figure out what that pressure drop is going to be, and that is a component loss. Then on the supply side, if we have a case coil, we may have a component loss anywhere around 0.15 or even higher. In fact, we need to be very careful about what coil we select to try to keep that component loss as low as possible. And the air is going to always pass through a supply damper. Now, we don't add up all of our dampers. We're only adding up one damper because we're looking at the longest run here. And so no matter which of those runs in the system is the longest run, they're always going to have to go through a damper. That's zero point 0.03 per manual D. And then finally, the supply register, whatever one that we select, that's also going to be zero point 0.03 or another number if we have that number from the engineering data from it. So all of these components add up together to 0.34. And that leads us to our available static pressure. That's what's left. So our available static pressure is our total external static pressure minus our component losses. In this case, Our available static pressure is only 0.16. That is the static pressure that we have to design our ductwork around. So as always, I hope that you join us Wednesday, February 19th, 6 o'clock to 9 o'clock p.m. Eastern Standard Time. Again, $40 per ticket. Everybody that buys a ticket is going to have a recording of the class. So even if you can't attend live, you will be able to benefit from the class. I hope you see you there.